Okay, so now we're gonna start looking at square roots. And so this first part we're gonna look at is basically the opposite of square root, which is a square. So they shouldn't be too bad. So let's see, 2 squared, let's see, that's 4. 3 squared is 9. 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. 8 squared is 64. 9 to the second power is 81. 10 squared is 100. And so you should definitely have those memorized right here, okay? But we're going to go ahead and do a couple more that hopefully we can memorize. So 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. 15 squared is 225. And 16 squared is going to be 256. So the main thing is you definitely want to know up to 10, and these other ones will be helpful too, okay? So what we're about to do is basically the opposite of squaring. Okay, we're going to square root. And so whenever you're looking for like the square root of a number is equal to, let's just call it, for all purposes right now, we'll just call it x, okay? So what you're really looking for is what to the second power equals the value inside the radical right here in. So you're just asking yourself, what to the second power gives me this value inside here? That's what you're asking yourself right here. Okay. Um, so we'll scroll down and try a couple of these. So like right here, 64, the square root of 64, it's going to be 8 because 8 times 8 is 64. And so you can go ahead and write your answer, but I'm going to show you another way of looking at this. So 8 squared, see, so I'm taking the square root of 8 squared. So what's happening is this radical is the opposite operation of squaring it. So they basically cancel each other out, and you're just left with an 8. And I'm showing you that because it's going to make this a little bit more understandable in a minute, because we're going to put some variables inside there, some letters. And so we kind of need to know that pattern right there, is that the square root nullifies the square power. Okay. Um, okay, so this is just some general information we'll kind of look at over here. So so sometimes we're not always going to do the square root. The first couple days it will be, okay? But sometimes we might do cube roots or fourth roots or fifth roots. And so you put that number right there, depending on which root you're taking. Typically, and you'll see this down here, typically if we're doing square roots, we could write the 2 there, okay? But this is one of the most common radicals we use. These are known as your radicals. So typically we just leave it empty, okay? So you don't have to write the 2 there. You could if you wanted, but it's not going to be necessary, okay? So you can see right here, this is your radical sign, okay? The index is what I was talking about. So sometimes we'll do other roots, okay? And so we'll wait and we'll talk about that in a later section. The whole thing is known as your radical. The value inside we call your radicand, okay? So anyways, this up here just kind of goes over what I already talked about. They're just using different letters. So the nth root of a is equal to b means that basically you're looking at what value to that power right there gives you the value inside the radical sign. So today we're only going to have to worry about square roots, so we're not going to go past that. So right here, the square root of 49, it's going to be 7, but just to kind of, once again, to hammer that home, so 7 squared, and so what happens is the radical and the power cancel out, and you're just left with the 7 right there, okay? This next one, they throw a negative in front. That's just like having a negative 1, like you're multiplying your result by negative 1. So you're going to have negative 1 times, and the square root of 256, if you were to kind of look at our cheat sheet, that's what this is going to be for up here, is to kind of help you when you're doing your homework, and when you sit down and take the test, you might want to write this down as you get started as like a little cheat sheet to help you. So you can see that right here, this is the same thing as 16 squared, and then when you square root it, you would just be left with 16. So here we're going to be left with negative 1 times 16, which is then just negative 16. Oops. There we go. All right. Um, so this next one, you got the square root of a negative 121, and so it's inside the radical sign. So you might be thinking, oh, it must be negative 11. But actually it's not. If we come over here and we look right here, I do have a note right here. If you square root a negative value, it actually is known as being non-real, okay? And so we can kind of talk about this because basically what you're asking yourself is, we'll just call it A. What to the power of 2 would give you negative 121? What would give you that? And it's kind of hard to figure that out. And so um, at least numbers that we're aware of, we're not aware of anything that you can square and get a negative result, because whenever you square something, it should always turn out to be a positive, as far as we know at this point in the course. So we call this non-real. Now, later on in the course, we'll actually there's been a number system that's been developed to deal with this phenomenon right here. Okay. But it's not anything that we're familiar with at this point right now. So right now we just call it non-real. Okay, so that'll be for another day in class that we'll talk about that special situation. So if you're doing your homework and you run across this, you'll just say non-real right now. Okay. Um, so right here, if you're adding something together inside the radical, you can go ahead and do that. So this would become the square root of 25. And then the square root of 25 is just 5, because 5 times 5 is 25. Okay. Now, 7 is different. You can't just add that together and say square root of 25. So you can't do that. It's got to stay separate because they each have their own radical sign. So you can't actually add these together. But I can evaluate them separately. So the square root of 16 is 4, plus the square root of 9 is 3. 4 plus 3 is 7. And there you go. Okay. So what we're going to do now, and we're not going to deal with this too much in the course, just really right here. We're going to do estimations of taking square roots of values that aren't perfect squares. So far these have all been perfect squares. They've all come out to be whole numbers, and so they've worked pretty nicely. These next couple are not. We preferably do not like to write decimals on these, but I think this just kind of exposes students a little bit more to have a better understanding of what these radicals are, though. Okay. Okay, so right here it says estimate what two whole numbers the following square roots are between. Then evaluate the square root using a calculator, and then we're going to round 2 decimal places. So there's 2 things they're asking us to do. They want us to estimate between what 2 numbers this is between, and then also then we'll just go actually use a calculator and come up with that. So square root of 30 is between the square root of 5 and the square root of 36. So this answer has to be somewhere between 5 and 6. So that's part 1. Okay, it's got to be somewhere between 5 and 6. Because square root of 25, I'll put this right here. So square root of 25 we know is 5. Square root of 36 we know is 6. So the number we're looking for is somewhere between here. It's going to be 5 point something. And so now I'm going to go ahead and grab a calculator so we can do this. Let's see. Oops. All right. Let's see. Okay, so I'm going to go ahead and type in 30 and press the square root key. So I get 5.47722, so on. So it says 2 decimal places. So I have to round it up to 5.48. So let me write that down and then we can talk about it. So 5.48. And so those little squiggly lines indicate that I'm estimating, that it's an estimation. Okay. So going back to my calculator, so you'll see that right here, I had 5.47, and then if the number after your last decimal place that you're rounding to is 5 or higher, you have to round that last decimal spot up. So we'll see one where I don't round up in a second, but this one I had to round up to 0.48. Okay, so this next one is the square root of 51, so the perfect squares between that would be 49 and 64. Well, the square root of 49 is 7. The square root of 64 is 8. So we're looking for something between those two numbers. So it's going to be like 7 point something. It's pretty close to 49, so it's probably going to be like 7.1 or something like that. So we won't guess. We'll go ahead and put it in the calculator and do this. So let's see. I'll clear this out. So 51, and I press the square root key. So I get 7.1414. Okay, so two decimal places. So I have a 4, and then after it's a 1. So since that third decimal spot is not 5 or higher, I'm just going to keep it at 7.14. So here we go. So 7.14. Okay. All right, so I got a couple more left here. So I got the square root of 125. So if you were to look at your perfect squares, you got 121 and 144. So we're looking for something between 11 and 12 in this case. So 11 point something. So 11, well, let's go ahead and find it real quick and then I'll write it down. Okay, so grab my calculator. See, so 125, and I'm going to square root that. So I get 11.18, and then there's a 0 afterwards, so I don't have to worry about rounding, so it's just 11.18. Don't have to round up. So 11.18. And there you go. And so just to kind of think about this, what's going on is if you were to square this number, it would be 125, or at least very close. So the last one we're going to look at, I believe, is, let's see, so this between the square root of 225 and the square root of 256. And so we're going to be between 15 and 16 on this one. So it's going to be 15 point something. And so we go ahead and grab our calculator, clear that out. So let's see, 247, and we'll go ahead and square root it. And this one we have to round just like the first one. So you see that after the third decimal place is a 6. So we got to round that 1 up to a 2. So this is going to be 15.72. So 15.72. There we go. Okay, so like I kind of said when we started these, you're actually not gonna see a lot of this. So you'll see a little bit of this in your homework. But after today, you're not going to see it done this way. You're going to see it done a different way where we don't get decimals. We're not actually very big fans of decimals because they're not exact answers. They're estimations. Okay, so the last part of this first section is we're going to throw in the variables, okay? So this is what I want you to remember, and I talked about this at the beginning. So the square root nullifies the power of 2 right there. That's what's going on. So what happens is boom, boom, those cancel out, and you're just left with whatever is inside there, okay? Whatever's inside there. So there's a couple different ways you can look at this. The classic way of doing this is to manipulate this to have a power of 2 somehow, okay? So this goes back to your properties of exponents. That goes back to the very first week of class, okay? And so what you're going to have to do here is we're going to manipulate this into x to the second power raised to another second power. And see, power to a power, hopefully you recall that you multiply those. Now you don't want to actually multiply them back together, but what we're going to see here is that the radical cancels out with this power right here. So you're just left with what's inside this parentheses. And so the answer is just x squared. That's the answer to the first one, okay? Okay, so another way, or continuing with this way on number 13, so we're going to manipulate this into the square root of w to something raised to the second power. So we're trying to manipulate this. So the powers are going to multiply, so this should be w to the third power right here, okay? And so this is equivalent to what I have written up here on 13. Now what we're going to do here is this cancels with this, and we're just left with, oops, w, let's see if I can write that a little bit better, w to the third power. So w to the third power is the answer for that one. Okay, so now moving forward we have numbers and variables. Okay, so this is something I'll we'll see in the notes later, but I should have probably added it here. But basically, if you have two things getting multiplied together, let's just call them A and B, you can go ahead and just split them apart, and they can each have their own radical. And so you don't have to do that here, but I think students probably find that, especially if this is new to them, that's a technique they like to do. So what we can do is basically break this into two small problems that we should actually already know how to do at this point. So we break it into like two small problems. And so the square root of 49 is 7. And then the square root of x to the 8th power, you might have kind of started picking up on the pattern here. And what that is you can divide the index into the power, and that'll tell you how many you have here. So it should be x to the 4th, okay? And so if you remember, the index is this value right here, which typically on square roots we don't write it, but it's understood as a 2. And so 2 goes into 8 4 times, so x to the power of 4. And it's just kind of a little bit of a shortcut, so you don't have to always keep rewriting it. But it is good to know this so that, you know, if you do get confused and forget how to do it, this is the way you do it. You manipulate it to having a power of 2. So I could have wrote this as x to the 4th raised to the 2nd power, and the radicals canceling out that power of 2 up there. Okay, so I've got 3 more for us to look at in this first section. So you can do the same thing right here. You could break this into the square root of 16 times the square root of a to the power of 10, okay? And so the square root of 16 is pretty simple. I'm going to show all my work on this just to make sure everything's clear. But if you're feeling comfortable, you can skip the step I'm about to show. But what I'm going to do here is I'm going to write this as 4 to the 2nd power times the square root of, this is going to become a to the 5th raised to the 2nd power, okay? And so what happens is those square roots cancel out the square powers. So this cancels with this, and so that gives me a 4. This cancels with this, so that leaves me with the a to the 5th power, so a to the 5th power. And so like I said, I mean, I hope that you eventually get to the point where you're comfortable just going right directly to your answer. I'm not saying that you should be at that point right now, but the hope is eventually get kind of comfortable with these and you're good with that, okay? All right, so these last two, the numbers get a little bit larger, but it's really not all that difficult, and we add an extra variable. And so if you want to, you can break this up to where they all three have their own radical sign. So square root of 169 times the, or I'm sorry, 196 times the square root of x to the 14th power, and then times the square root of y to the 26th power. Okay? And so if you look at your cheat sheet, you'll see that this right here will be 14, so you get a 14. And then, like I said, if you want to, you can divide the index into 14 right here, this power of 14, and get you a 7. So that reduces to x to the 7th power. Okay? And then same thing with this, you divide the 2 into the 26, so you're going to get y to the 13th power. And there you go. Now, if you want to do it like I did on the previous problem, that's fine. And the truth is, you know, eventually we're going to do higher than square roots. We're going to get to cube roots and all that kind of stuff. But we'll spend some time on this. But this is kind of the traditional way of doing it, and I'll revert back to that once, like when we add new elements into the problem that kind of make it a little bit more challenging. I'll definitely kind of revert back to some of these more detailed explanations. Okay, so 17 is not all that different from what we just did here. So we could just do this all in our head right here. So square root of 121 is 11. When you square root the a to the 54th power, see, that's the same thing, just so I show my work, that's the same thing as a to the 27th raised to the 2nd power. So what's happening is that power of 2 is getting canceled out from the radical. And so that's going to give us a to the 27th. And then right here, same thing with the b. I could look at that as b to the 50th power squared, because power to a power you multiply. Same thing as b to 100. And so the radical is canceling out that power of 2. And so that leaves us with b to the power of 50. And there you go. Okay? So moving forward, you'll see that in the next section we're going to be simplifying these radicals. And so like the square root of 8, you can kind of see this one. You can't actually square root that without getting a decimal. So we're going to talk about techniques of simplifying it without having to do decimals.